All right, let us begin. All right, so we're continuing with the theory. We basically finished off the numeracy as far as I was aware. The last few things that we just want, or that I mentioned, were those different representations that weren't as important, things like the binary coded decimal and packed decimal representation. You won't be asked any questions about those, but they're just to say that there's more than one way to encode binary decimal information in binary, but it's not as efficient. So we use the encoding scheme that we did before. And the most important takeaway in terms of things that you'd probably get asked in a semester test is to know how to do the conversion table, which we will practice in the run-up to the semester test. But just to summarize, it's one column of zeros, 8 zeros, followed immediately underneath by 8 ones. In the next column, 4 zeros, 4 ones, 4 zeros, 4 ones. Then in the next column, 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones. Then alternating zeros and ones in the final column. Then you count from 0 up to 9 and A through to F. And then you've got your conversion table for binary to hexadecimal, binary to octal, octal to binary, all of those variants that you may need. So it has a lot in those questions. Please note that, as before, the chat is not on yet. We haven't received permission. I'm going to start sharing my screen now. If you do need to ask something, you can ask in the Discord server. They haven't told us we can't have that on. Share screen, so it should come through now. So what we're going to take a look at today is we're going to take a look at the design process. You have slides for that now, because you were given a pre-made mostly design for Practical 1, but it's important to know how to do designs for your own practicals going forward. And we'll take a look at a piece of software for doing the UML diagrams. During my tutorial on Tuesday, I used an online site which works okay. It's nice because you don't have to install any software. Today I will give you an alternate view with a piece of software that can do those designs as well. So it doesn't matter really so much what piece of software you use, as long as your designs follow the rules for UML, which we will describe again, then you should be okay. And then I'll take a look at accessing the VPL, and I'll do the VPL assignments with you for this week. Obviously, in future weeks, you'll have to do them yourself. But this is just to help ease you into the process of doing those things. The VPL assignments, remember, they're supplementary. Their purpose is to help you gain practice. We had lots of students asking, how can I practice? How can I practice? This is one way to practice. We'll keep the VPL assignments closely aligned with the practical you've got due, so that they will help you prepare for that. So let's begin. So let's just to keep reminding people, let's do this from the point of view of a student. Let's say I'm a hypothetical student with username 1, 2, 3, 4, 5, 6, 7, 8, 9, and my password will start out as the same thing, but should be changed once you log in. And we can access the lecture notes under lecture notes, and you can see that the one on the design process is over there. Also do take note that I have uploaded the sample practical design. We did that earlier, as well as all the past semesters 1 papers from 2011 up to 2020. You won't get any memos or anything like that, but you will get, we will work through some of those past papers as we get closer to the first semester test date. So you will have those memos in a sense of the ones we work through. So we'll work through them in sort of reverse chronological order. So the ones that are closest to now in time are the ones that will be most similar to what you need. So if you do those ones, you can then compare how you do with how we do. Obviously, we haven't covered the stuff yet, but you can really take a look and see what things you can answer at this point in time. And so here we'll be working on the design process slides at first. So let's take a look. Okay, so your design document accompanies every practical, as well as, importantly, your second semester test and your exam. Your second semester test and your exam are actually basically the same thing, in the sense that they cover exactly the same work and have the same level of difficulty in the same time, which is 2 hours, and they're programming oriented, to the point where if you do well enough in your second semester test and your semester mark is therefore high enough, you can promote in this course and not have to write the exam, because it is basically the same kind of work as the second semester test. So it's worth doing a good design, because as you can see in the breakdown of the previous exams mark sheet, you can see that the design counts 10%. That's an entire symbol's worth of marks, and it's fairly easy to do. In fact, it's fairly easy to get most of the marks fairly quickly. So we'll talk strategy when we get closer to the time, but well, I can even mention it now. The UML diagram does take a bit of time. So in terms of strategy, I'd advise doing the rest of the diagram of the document first, and then the UML after you finish programming your semester test 2 or exam submission, because you don't want to spend too much time on a diagram when you could be programming. So that's something to think about. So it's a PDF document preferably. I mean, you can write it in Word and then save to PDF. It's very easy to do that with reasonably sized fonts, 12, 14 for headings, bold, underline, things like that. We're not going to lose marks if it's slightly different, but just don't make these very miniature design documents, or these ones that are artificially inflated with a massive font size either. So those are reasonable values, which we will be quite happy with. And as a document, it contains several sections. It contains a problem description, which you will summarize what you need to do and give it back to us. It will contain a description of what the inputs and outputs are for your system. And you can have various forms of input and output, as you'll learn going forward. You need to structure your storage of the data in some way. So you'll describe that in the data format section. And then there's 2 different ways you can describe the algorithm. So just again, for what it's worth, an algorithm is the series of steps that you need to take to transform some input into some output. So it's like a recipe that you follow to get a certain result. And you can write it out in a way that's almost like computer code, in the sense that every step is clearly laid out and it's trying to be as clear as possible, even if some of the low-level details aren't specified. We call that style pseudocode, and the other style is as a visual diagram in the uniform modeling language, universal modeling language, which is a particular kind of diagram called an activity diagram, which is the modern successor to those older data flow diagrams that you might have seen if you've ever looked at an old textbook, or if you've ever seen older content about software engineering. They used to do these flow diagrams. It's the modern equivalent of that. Unfortunately, the online tool that I showed you guys yesterday has some of the conventions of those older tools, of that older approach in it, which isn't strictly speaking correct, but we'll clarify exactly the way that we like it, that's conformance with the UML2 standard. So your problem description is a summary of the problem given back to us. So the point is to basically show to us that you've read the problem and you've sort of broken it down in your head so that you understand it, and then you're able to rephrase it to us. So you can't just copy and paste the problem description from the question paper. For one thing, that'll be a page or page and a half long. So that's way too long. You need to basically summarize the whole thing in a paragraph or 2. And then for some cases, if something is very clear, you can reference the practical description you're provided with, but then you must reference it properly using the UJ Harvard referencing style. There's stuff in the general undergraduate learning guide regarding references and citations, as well as if you look at the UJ Library website, they have a complete guide to the UJ Harvard style. So if you do that, then please at least reference it properly. But to be honest, I'd be much happier if you read the problem, understood it, and gave it back to me in your own words entirely, because it's that act of taking it in, processing it, and giving it back to us that helps you start to understand what you need to do. So the software that you create, these programs, can be seen as a black box. So a black box is something which has values that go into it, and then some unknowable process on the inside happens, and the values come out on the other side. So that's often when people are designing software, they first think in terms of little black boxes with values going in and values going out, and later on they'll get to the detail of sort of figuring out what must go on inside those boxes to do the transformations that they want. We call this sort of a top-down design, where you first think of the overall structure of your system and then figure out the details later. Alternatively, some things are better done with what they call a bottom-up approach, where you focus on exactly how values look and exactly what you can do with them at first, and then sort of figure out how you can group things together into sort of units of functionality that can operate on the data that you've already examined at a very low level. So both of those approaches, bottom-up design and top-down design, have their place, but particularly in a software engineering context, it's much more common to look at things from a top-down approach, where you look at the connectivity between parts of your system first and figure out the details later as you go forward. So in order to do that for your program, you need to specify what the inputs are, so give descriptions on what it is and how we're getting it, or the output in that case, what it is and how we're displaying it. For now, the only kind of data input output that you have is data that comes from the keyboard as input and data that goes to the terminal screen as output. In later parts of this course even, and definitely very much in Computer Science 1B and other computer science courses, there'll be many different ways of inputs can come into your system and outputs can go out from your system. We could read values in from files, we could get values from the network, we could connect to databases and read and write values, lots of possibilities. So that's why we specify the mechanism now, because it might be something that changes later. Then for your data formats, you must specify the name of the identifier. So if you remember from the tutorials, an identifier is a name that we as the programmer must assign to various things in our program as we write our program. So the most obvious of those is the named storage locations where our values will be stored, which we refer to as variables. And as you've also seen, there are certain rules that apply to the kinds of values that can be stored in certain places. And these rules are called a data type system. And we've seen so far in the tutorials that you can have character data, or that you can have Boolean data, which represents truth and falsehood. You can have sequences of characters, which we use a string for. You can have numbers that don't have a fractional component. We call those integers. And we can have numbers that may have a fractional component as well. We call those real numbers, of which the kind we use are called doubles, which basically the reason for that ties into the work that we did yesterday when we looked at the number representations in binary, and we saw that you can get, when you've got fractions, repeating recurring fractions, and it happens in binary and it happens in decimal. And you can't store an infinite amount of data in a finite amount of bits. So the initial real number data type was called float, which still exists, but it doesn't use that much space to represent the number, and that means it's not very precise. It means that you can get values that are slightly off what they should be. And for that reason, we tend to just default to using another real number data type called double, which basically has twice the amount of space allocated to it as a float does, and is therefore much more precise and accurate than a float is. When you deal with real numbers, you always have to understand that there's a certain imprecision, a certain level of vagueness about those numbers if they have a recurring component which means you might not precisely get the value you expect. Then, as I said, you need to write down your algorithm in pseudocode formats, which basically means it's kind of like a mix between English and an actual programming language. The word pseudo actually means false, and you'll see it again when we look at random number generation, because computers are unable to create genuine random numbers. We refer to those as pseudo-random numbers, so false random numbers. This is sort of false code. You could never compile it and run it. So there is no programming language that exactly matches pseudocode, but it's close enough to a program that someone who knows how to program could read it and then turn it into their programming language of choice. You can also mix in mathematical notation and various other things that are relevant to your problem domain, for example. You tend, when writing an algorithm in pseudocode, to be a bit more declarative rather than imperative. You basically describe what you want without necessarily going into the exact details about how you get there. Likewise, pseudocode doesn't use manifest typing. We don't have to say this identifier is a character and then store characters inside it. It's sort of implied that the type will be whatever it needs to be to store the thing. As you'll see when you learn more programming languages, not all programming languages are like C++ and use manifest typing. Many of them are dynamic in their typing, and you can store different values in the same identifier. That has advantages in that it's quicker to use, but disadvantages in that it's more prone to errors. So both are different use cases that you might want in different situations. Also, pseudocode isn't limited to the mathematical operators and input-output operators that exist in C++. So, for example, it's very common to, rather than have an equal sign, to rather have an arrow in pseudocode to show where values are being stored, and to use English verbs for complex operations. So what you mustn't do, and what students are often very tempted to do, is to write their C++ code first and then copy and paste it into their design and then just change a few small things and pretend that that's now pseudocode. That's not correct. I know it's very tempting to do so, particularly for people who are stronger programmers, but you're supposed to do your pseudocode first. You're supposed to have thought through the program's logic before you start coding, rather than code it first and then fake the design afterwards. Although I know that many students do that, and to be honest, we can't really tell, but we can definitely tell when you copied and pasted your C++ code into your design and pretended to make it into pseudocode. So here's an example for a pseudocode for testing the calculating semester marks for students. Actually, the formula for this one's actually out of date now because it's the formula that was current back in 2014. So we can adjust it for you from your learning guide. If we do an example of this today as a program, then we can adjust it to your precise values rather than ours. But the basic idea is the same here. So you can see here, this one's using the mathematical for each student that is an element of the set Computer Science 1 students, or you could just literally write that out in English for each student in Computer Science 1A students. Then you can see we're getting the name. We don't say where the name comes from. Presumably it gets typed in the keyboard, but those details aren't important. We simply say extract student name, capture their practical mark, semester test 1 mark, semester test 2 mark, calculate their semester mark according to the weighted average, calculate the practical component mark according to the weighted average. This formula is slightly different for you now. And then compare the semester mark and practical component mark to the thresholds. If they're both above the threshold, you can output has access to the exam. Otherwise, you can output has GTE, which is the code that the university uses for failure to access the exam. It's from the older system. It stands for geen toelating voor examinatie or something like that. But basically doesn't have access to the exam. And the point is you must pass both your semester mark and practical component mark threshold to gain access. But the point of that isn't so much the orientation stuff. We covered that last week. The point of that is this is a description of the algorithm in pseudocode. You can see it doesn't look like C++. It also doesn't look exactly like the pseudocode that you saw in the sample design that you were given. So that also shows there's a lot of flexibility in what your pseudocode looks like. It's not meant to be as precise as a programming language. It's meant to simply be a broad description of what you should be able to see. Also that means to us that two people's pseudocode for a complex program should not be identical, and it's a very bad sign if people have the same pseudocode. So don't do that. All right, now we can see there's the last part of the design, which is the graphical representation of the algorithm using UML. It's a visual notation which is used in software engineering. There are many kinds of diagrams in UML that refer to all sorts of different aspects of software engineering. But the activity diagram is very good at representing sort of procedural programming algorithms, which is what we will use it for. And it's made up of a series of components. And those components are the initial states, which is a solid circle. That's where your program starts. One or more final states. So your program could end in one place, but it could actually end in multiple places. There are some people who advocate and say that your program should only really end in one place. You should design your logic so that all of the flow of logic in your program ends in one place. Others say that that makes it too complicated. I say it does depend on the situation. If you can do it, it's nice. If you can't, don't sweat it. Then you've got the activities themselves. The activities are basically small units of work that can be done in your program to take you one step closer to completing your algorithm. So your algorithm should transform whatever inputs you give to it into some form of output. Each activity should be a step in that process. Sometimes you need to make decisions though. Test if values are true, do things multiple times, anything like that. You'll use a branching point, which is the equivalent of the if statements we looked at, as well as looping constructs like the while that we looked at in the learning guide, in the tutorial this week as well. So there's no separate notation for different kinds of flow control. There's only these branching points. And then basically the flow between these different steps is given, or these different components is given as these transition arrows. But sometimes you need to specify what the reason is for following a particular one, particularly if it comes after a branching point. And if you ever need to do that, you put those in brackets as a conditional expression, which should be some expression that is Boolean in nature, as in it evaluates to either true or false. It's something you can read and say, yes, that's true, or no, that's not true. So here's an example. It's that PCM calculation using the older weights, but still the logic is correct, for processing a list of students and calculating whether they have exam access or not. So in the initial state is there, that's where the logic starts. Then we select the next student from the list, whatever that list might be, capture their biographical details, presumably that's their name and other things about them, then capture their results, that's the semester test 1 mark, semester test 2 mark, and their practical average. Then we make a decision. Was their semester mark high enough or not? If their semester mark's too low, they automatically don't have access to the exam, which is unfortunate. So we output that that student has not got access to the exam, and continue to another branching point where we check to see, are there more students or are we done? If we're done, then the program ends. If we're not, we go back to selecting another student from the list. So we can follow that logic back down again. Let's say now that the next student semester mark is above the threshold. Well, that's wonderful. We then need to make another decision and decide whether their practical component mark is above the threshold. If it's not, unfortunately, no access to the exam, same story. But if it was greater than the threshold, we can output, yay, you've got exam access. Then go back to that same decision and either continue with the next student if there are more students in the list, or when all the students are processed, we're done and the program ends. So that is the basics of a design. You've already seen an example, but I thought maybe these slides would be helpful as supplementary information for that. So I'm now going to take a look at the Discord if there are any questions and go through them. Okay, presumably some people can't see the screens. Apparently sometimes you do have to reload, which other people have mentioned. The VPL assignments, let me be clear. They are for marks, but they're supplementary marks. So basically, they help you get your practical mark high, as high as it possibly can be. So the VPL assignments, you can get 100% if you just do your weekly practicals, right? That's definitely possible. But the VPL assignments go into the same pool of marks. And from that pool of marks, we pick the top however many marks. So the more VPL assignments you can put into that pool, and the more things you do, the easier it is to get full marks for the practical mark, which just helps you get your semester mark up as well as get your practical component mark up. So they're supplementary, but they can really help, and they can't hurt you, because if you do attempt them and it goes badly, then that mark just won't be one of your top marks, and it can only help you. Okay, you can have a list of identifier formats. Okay, so you mean data types? Oh, you mean for the coding thing? I suppose we could put a notice up for what the prefixes are. That's basically what you're asking for. That's a good question. Thanks for that. Just remind me if I don't do it. Do gambling sites and lots of companies generate random numbers via computer if it's pseudo? That is a very interesting question. And what they should do, and also what some security companies do, is you use a physical real-world process to get that randomness into your code. So, for example, you can measure the decay of a radioactive isotope. That's going to be as close to random as is physically possible in the universe. There's, I think it's Cloudflare, the big sort of content provider cloud thing. They use lava lamps, and they have these cameras aimed at lava lamps, and they watch how the lava lamps move to be the random input into the system. So there are lots of ways, and they often involve connecting to the real world. Sometimes you can measure things like the exact electrical current in certain parts of your computer, which will be within a certain range, but the exact value might be subject to real world randomness. Lots of stuff like that. So really interesting field that. Can you use logical operators in pseudocode? You absolutely can, definitely. So process flow diagram. It's the modern UML activity diagram is the modern successor to a flow diagram. So the ways in which it differ is you don't write the. Let me just show you. Oops, that's the old stuff. You don't write the reason for branching inside the diamond. You write it as a label for the transitions. That's actually the main difference. Everything else is pretty similar. So it's very much like a process flow diagram. It's the modern equivalent to that diagram. Obviously, there are some places that still use the old process flow diagrams because the idea being, if it ain't broke, don't fix it. But this is the UML standard for it. So if you want to follow the standard, that's the way to go. So very good question. Is the design completely different than the informatics design documents? To be honest, I have no idea. It's been a very long time since I've seen an informatics design document. I last did Informatics 1 in 2001. And I've never been an assistant for informatics. I've never been a lecturer for Informatics 1. I do help out with Informatics 3 sometimes, so I don't know. You do what your informatics lecturer tells you in informatics. That's their business. For the practical, should we include some sort of exception handling? You don't have to, but there's no harm in practicing. Later ones will require that sort of stuff. We will only do proper exception handling much, much later. But if you just mean error handling, then you know enough about if statements to do that now. You can add it, it's not a requirement. And then how do we gain access to the VPL? Excellent question. Let's do that right now. All right, so for the VPL, how do you gain access to it? Well, if you look at your marks, you'll see under your marks, you've actually got a password. So under this password is your VPL password for the system. Ignore the /0 at the end, because that's basically all about, these are mark fields, so it expects them to be out of a certain amount, out of 0, something out of 100. So this is your actual password. Just ignore that trailing slash. Right, so that's our password. Well, not your password, that's the password for the made-up student we have here. So the student number is 1, 2, 3, 4, 5, 6, 7, 8, 9. So their VPL username will be VPL dot. So we should be able to access the VPL system using those credentials. So if we go to the VPL system, that's axi.cloud. So hopefully I should get the security certificate exception here, because I did try to purge the certificates, but I'm not sure if it's cached anywhere else. Okay, but let's log in. All right, so we use our username is VPL and dot your student number, and the password is the one that you got from that mark field on Eve. Okay, should be okay. Here's hoping. And that worked. So you can see we've now gotten access to the VPL system, and these are the VPL exercises that are available to you now. We'll release them in batches as we do various things. So the next batch will be around what's in Practical 2. This batch is just the absolute basics. So let's take a look and do the Hello World program here. All right, so how do we enter our stuff in the VPL? Well, you click on exit and on edit. And then, okay, I've already done some stuff here. Let's get rid of all of that. This basically system, for what it's worth, it provides you with a way of coding, even if you haven't got code blocks installed as well. So if you really are struggling to install code blocks on your computer, you can play around in the VPL and do all the coding that you'll need to do without actually having to have code blocks installed. So theoretically, you could code your systems on VPL and then download them or copy and paste them into text files that are named properly and submit them to Eve for assessment as well, if for your weekly practicals, if you really can't get code blocks running on your home computer. I'll actually add an extra VPL exercise that's just sort of free form for you to do whatever you want with as well. So it's not ideal. It's much better to work on code blocks on your machine and submit that, but it is better than nothing if you need to. So important thing is, if you do start out, just see if I can do this now. I'm going to delete main.cpp here, save. We come back to this. And then it asks us, please create a new file. Very important that whatever file you create ends in .cpp, because this system can actually process a whole bunch of different languages, but it uses the name of the file to decide what the language it's going to use is. So it looks at the extension, in this case .cpp, and realizes it's a C++ file, and the convention we're using is to name our things main.cpp if it's the CPP file that contains main in it. Right, so in this case, create a program which prompts the user for their name as a single word, then outputs hello world followed by that name. Hello world from followed by that name. So let's test that. Let's maximize this. And as we saw in the tutorials, we need to bring in the input-output system. That's IOStream. We need to make use of the standard namespace that brings in all of the names from here into this program so that we can use them easily. We have the entry point for our program. That's called main. That's the unit of functionality, the function, which always starts first in any C++ program. It gives back an answer, and we'll discuss that in much more detail when we do functions, of type integer, which basically just represents what error occurred. And if we say no error occurred, we return 0. That means everything was fine. Then we need to prompt the user for a name. So we're going to do that. We're going to say enter name. We need a place to store it, and it must store text data, because that's what a name is like. So we'll create a string, which is the type for storing text data, and we'll call it str main. That seems reasonable, and we'll give it an initial value of the empty string. Strings that occur in your code directly are called string literals, and they start with a double quote and end with a double quote. And then you've got the string identifiers that you'll be creating, which are given a name, which we start with str. We then want to read in from the keyboard into str name. We use the standard input stream and read into str name. Here we use the standard output stream and sent the prompt enter name to it. So now at this line of code, line 10, we should have the str name stored whatever the person said. So now we will output the thing that we're told to. So that's hello world from, followed by that name. Notice there it looks weird. It doesn't look blue like we saw before. That's because that's not a string. And then we want our name that we entered to come after it. str name. Follow that off with an end line. Save here. It's going to save it. Now it's on the system. It's not going to disappear unless we manually delete it. If I click the little rocket ship, that's the run thing. It's going to connect to the VPL server, which is a separate computer that actually runs all the software. The reason that we do this is obviously to prevent a student from bringing the whole system down or from trying to hack the system by writing code that does weird stuff. So it runs off in its own little jail. So when I click this, it's going to try and connect to the VPL jail. And it's now yelling at me. It says, I don't know what the system is you're trying to connect to. I've never seen it before. It's because I manually deleted my certificates. Please tell me that you're okay with accepting that I will send data to it. So that's fine. So I click on that server 10 over there. And then it's like, hey, wait a minute. I don't know about this because it's not a security certificate I've seen before. That's because it's one we just created for it. So that's fine. So we go accept, click continue. And then it says, okay, fine, you know what you're doing. And from now on, it should be able to connect and send our code to that server to run. So now you can see that it's running, and it's running on that server and sending the output back to us. So we don't need to have code blocks installed at all. So we can type in our name, and we get the output that was said, hello world from Duncan. When we're done playing around and we want to test like whether we were right or not, there's a second button here called evaluate. That will send it to the server again to run and get recompiled. But we will have a bunch of input and output that we will send to your program, and we'll measure how often your program is right and give you a mark based on how often your program is right. So if I click on evaluate, we'll see it again does the same process that it did before, and then it gives us a summary of test results, and it says we passed the test and our proposed grade is 100 out of 100. So if we want to, you can even view for your submissions how they've done, and you can see that this one passed and is fine. The actual VPL code will only be given to you at the end of the actual final results will only be given to you at the end of the semester, but they will continue. Will only be given to you at the end of the semester, but they will. You can see now what you would be getting, so you should have a good idea. So the final results will only be put on Eve at the very end of the semester, final week or so. We'll give you more information close to the time. Let's keep going. All right, so let's say we wanted to work out the area of a triangle. All right. So it gives us a formula for the triangle. So it's the height times the base divided by 2 for that particular kind of triangle. So we just need to write a program that reads in those two values, does that calculation, and outputs it. So again, we can click on edit. I've already got a solution there, and it's, oh, stop it. You've seen me create a new program. So let's just continue. Again, hash include IOStream. Again, using namespace standard. And again, at the end of the program, return 0, everything is fine. We then need to store two things. We need to store that HB and that B. So let's store those. Those will be real values. So we store that as a double. Let's say DBL HB. Give it an initial value. Let's make that 0. Then we want to store the base. So double, let's call it DBLB. Give it an initial value of 0. Keep these values in. You can. Some people prefer to declare all the variables at once and then do stuff with it. Others prefer to declare the variable as close to where it's needed as possible. So declaring the variable is where you say what its type is and what its name is and what its initial value is. And the variable will then exist from that point onwards until the final closing brace of the block that it was declared in. So in that case, at the end of main. So I prefer to, these days, create my variables as close to where I'm going to use them as possible. So I'm going to now go on to prompt the user. Yeah, so we'll go cout, enter HB, cin, read into DBL HB, and that's fine. Then same story. Okay, we've got 5 minutes left, but let's do as much as we can. HB, this time we're just capturing B. Lowercase b of that. Got about 5 minutes left, so let's just try and do what we can do. Can't really deal with hands up or anything at the moment. If you do have questions, ask them in the Discord, so I might look at them after the time is over. So now we just need to do this calculation, which is fairly straightforward. So you can store the results in a variable. Often that's a nice thing to do because you can then give the variable a name. So it's very easy to read the code. So we call it DBL area, and we say that we want to take DBL HB and multiply it by DBLB, and then divide all of that by 2. And then we want to output that result. Right, so let's test that and see how that goes. So we save, run. You see, once you've accepted the certificate, it won't prompt you again. That certificate will only change if we reboot the VPL server. So hopefully it can stay constant for a while, but now you know how to accept it. And then we've got entering HB, so I don't know, 10, 5, we get an answer. So let's test to see how close we are to right. We've got a test case there. If we click evaluate, and it will connect. And it's quite happy with our answer that we gave. Let's do it all wrong and just make sure that is still not going to now give us the right answer. So if we ran that, and it yelled at us because it didn't expect that answer. It expected 1.38 as its final answer for that. So that tells us that, oops, we did get the question properly correct. And there we have it. So that's that. I'm not sure if I'll have time to do all the others. That is certainly many of them. Let's take a look at what ones we got left. Okay, well, we did do things that were basically like this in the tutorial, so you could take a look at those, at the code for that. Yeah, so this is how you access the VPL system and how you work within that environment. And we've done 2 of the assignments for you. You'll have to look at the other 2, but it's very similar to what we did in the tutorials. And let's see if there's any other questions. Well, okay, good questions. Let's just take a look. Are they time-based? No, they're not time-based. You'll have until the final week to do all of them, but it's advised that you stick to the practical that they're close to. We'll start that lecture. Okay, so the slides for overview of computer languages and programming languages haven't happened yet. We haven't done that. You can see all of the practicals, all the lectures that have done on the list on Eve under notices. So you can see we haven't done that one yet. It's just there because it's the next thing we're going to do. The due dates for the VPL activities, look, there are on the system, but they're not real. So that we'll basically need to calculate all of those marks in the final week of the semester. So you have until the final week of the semester to work on them. Can one use Visual Studio 2019 in case of CodeBlocks? Yes, you can. Just as long as you submit your .h and .cpp files in your source directory, should be fine. Okay, we're about to run out of time and it's going to unceremoniously disconnect us. So I'll answer those other questions in text in the channel. So I wish you all a good evening and goodbye. And I'll answer your questions now. All right.